Good morning to one and all present here. I am Devi Abirami. Today I am going to explain the topic Introduction to Linear Programming Problem in Discrete Structure and Optimization Technique. In this LPP model, I am going to explain about the graphical method. Graphical method of solving an LPP. LPP is nothing but a linear programming problem. First, we have to formulate the linear programming problem. They will give a case study problem. For that, we have to write an linear programming problem. Each inequality in the constraints may be written as equality. For example, if there is an greater than or is equal to symbol, we have to change it as equality to solve by graphical method. Plot those constraints in the line considering them as equation. We have to consider the given equations and we have to solve those equations. By solving those equations, we will get a points. That point should plotted in the graph so that we will have a straight line. Identify the feasible solution region. The intersection of the lines is our feasible region. Locate the corner points of the feasible region. Calculate the value of the objective function on the corner points. Choose the point where the objective function has optimal value. We have to choose the corner points of that feasible region. For that corner points, we have to calculate the optimum point. If it is maximum, we have to calculate the maximum value. If it is minimum, we have to calculate the minimum value so as to obtain the optimum solution. Graphical solution of a linear programming problem. We can solve linear programming problem using two different methods. They are corner points method and isocost method. In this video, I have posed for corner point method, and in my upcoming video, I will post for isocost method. For corner points, we are having some algorithm. Our algorithm is step 1, to create a mathematical formulation from the given problem if it is not given. Now plot the graph using the given constraints and find the feasible region. Find the coordinates of the feasible region that we get from the step 2. Now step 4, evaluate the objective function at the corner points of the feasible region. Assume capital N and N denotes the largest and the smallest value of these points. Step 5. If the feasible region is bounded, then N and N are the maximum and minimum value of the objective function. Or if the feasible region is unbounded, then it has two cases. So our first problem is, as usual, we are going to formulate an LPP and we have to plot the values. Now we have to choose the feasible region, whether it is maximum or minimum, and choose the corner points which is greater and smaller. If it is bounded, we will get both the maximum and the minimum value. If it is unbounded, then n is maximum value of the objective function if the open half plane is got by ax plus b should be greater than n, has no common point to the feasible region. Otherwise, the objective function has no solution. There is no solution in this case. When n is minimum, our plot value ax plus b should be less than n, has no common point to the feasible region. Therefore, the objective function has no solution. When it is an unbounded case, we cannot find a solution for that graph. My first problem, example of an LPP using a corner point method. Solve the given LPP model graphically. My problem is max z is equal to 8x plus y and my constraints are x plus y less than or is equal to 40, 2x plus y less than or is equal to 60. X greater than or is equal to 0 and y greater than or is equal to 0 is my non-negative constraints. First, we should consider the inequalities as equality as an equation 1 and 2. That is, x plus y is equal to 40 and 2x plus y is equal to 60. First, we should substitute x is equal to 0 in equation 1. We have to find the value of y. Similarly, we have to substitute y is equal to 0 and we have to find the x value. So that our point is 20, 20. I have plotted my constraint as 20, 20. Okay, by substituting in my second value, I have plotted my graph as 20 comma 20, 30 comma 0, 0 comma 40. So this is my points of the given equations. By plotting this, I have pointed the corner points of my feasible region. So my corner points are 0 comma 40, 20 comma 20 and 30 comma 0. By substituting in my z value, I will get the maximum value as 240 at the point x is equal to 0 and x is equal to 30 and y is equal to 0. This is how we have to calculate the maximum z by using graphical method. Thank you.